Okay, guys, this is Estimating with Confidence, section 8.1, and this is confidence intervals, really just the basics. As we go through this, I'm going to kind of just get you through some of the things. This first section that we're covering today is, it is just the basics. We're going to go into, if you look on the board, we have estimating a population proportion. We have things talking about sample size, how to estimate a mean of the population. We're just going to hit the basics, and then we're going to see how we fare from there. But as we go through this, after this section, hopefully we're going to know what is a confidence level. We're going to know how to interpret a confidence level in the context of a problem, describe how a confidence interval gives a range of possible values for our parameter. We will also describe the conditions that are necessary to construct a confidence interval. It has to meet certain conditions before we can even do this. And we're going to explain issues that can affect how you interpret a confidence interval. So one of the biggest things is, how do I interpret this interval? And we're going to clear that up hopefully today. All right. So our goal in statistical settings is to use a sample statistic to estimate the population parameter. So we don't want to use the population. Why? Because it's too big. So we're just going to use a sample to estimate it. And in chapter 4, we came back here and we learned from chapter 4 that if we randomly select a sample, so if we can just randomly pick a sample here, then what we will get is, oh my goodness, okay, if we randomly select a sample, we should be able to get the population, and it should be close to our results. All right, and then in the last chapter, we learned that different samples could give us different results. So depending on what you get in the sample you pick, you can get different results from one sample to the next. Now, inference uses probability and how strong our conclusions are. So like now we're going to say, how confident am I in the conclusions that I got? And in this chapter, we're going to learn one method of inference, which is confidence intervals. Remember, inference is making a conclusion. Confidence intervals helps you make a conclusion to your audience. So we're going to estimate the value of a parameter or the population from a sample statistic. As we do this, we'll learn how to construct a confidence interval, but also how to report probabilities that would describe what would happen over time. So we're describing what would happen if we did things multiple times. Right? Now, your teacher has selected, it says a mystery mean value and stored it in their calculator. It says your guess is to work through and find what that value was. Okay? The value is 240.79. Basically, what this tells me, when you do the mean and random norm, it tells me that the calculator chose a sample of 16 observations with the mean and the standard deviation of 20 and got a mean of 240.79. Okay, that's a problem that we did as an activity. We don't need to do it today. And we'll go through that later. Okay, now, if you had to give one number to estimate an unknown population, what would it be? If you were estimating a population mean, which is called mu, anytime you talk about the population, you're going to use x bar, which is the mean of your sample. If you're estimating a population proportion, which is p, you're going to use p hat, which means your sample. In both cases, you are providing a point estimate. So what you're doing is you're estimating from a sample what the real mean is, or the real population is. So there's a definition for you that you really need. A point estimator is a statistic that provides an estimate of the population. The value of that statistic from a sample is called a point estimate. Okay? Ideally, a point estimate is our best guess at the value of an unknown parameter. So there's this unknown population. This is our best guess that we got from our sample of that population. So we're going to take our best guess at it. That's what a point estimate or point estimator is. Now, an ideal point estimator. So ideal will have no bias, which means what? That means it's at the mean. Bias means it's far away from the mean. So it should be at the population mean. Low variability means they should all be close together. Variability is almost always present when you're doing samples because you don't have big numbers. So we've got to extend our thinking to include an acknowledgement that repeated sampling could yield different results. What that means is if I take a sample of 20 students, I could get a result, and then I could take a sample of 20 other students and come up with something a little bit different. That's not going to change things, okay? So just because I take a sample, we've got to take into account, all right, this isn't like 100% truth. So notice when we do confidence intervals, we never say 100% because things can change from sample to sample. All right, next, the idea of a confidence interval. And we'll keep going through that. Let me pass that one because we're not worried about that. But the idea of a confidence interval is to say, how far away from the mean are we? Okay, so basically the definition of a confidence interval. The big idea is a sampling distribution of x bar, which is the mean of our sample, tells us how close to the actual mean of the population the sample mean is. So let's think about it. If I got a group, let's say we're talking about ACT scores. If I got a sample of like 20 people, their ACT scores, the sampling distribution, the average should be close to the population average. Okay, but how close is it? Well, confidence interval will help me figure that out. So here we go. Estimate plus or minus the margin of error. The confidence interval has two parts. The interval is this, estimate plus or minus the margin of error. We're going to be using that in just a minute, so you want to make sure you have all this written down. The margin of error tells us how close the estimate tends to be to the unknown parameter in repeated random sampling. So if you sample over and over and over and over, it'll tell you how close your estimate is to the population. Now, a confidence level, the overall success rate of the method for calculating the confidence interval. That is, it gives you a certain percent of all possible samples. This will give you an interval that captures the true mean, so the true population. Basically, I can say I'm 90% confident that if I do these samples over, I can say I'm 90% confident in it, and my confidence level tells me that 90% of the time, I'm going to get the true mean in my sample. So if I knew what the true mean is for the population, if I take this sample, I know that 90% of the time, I will get that true mean in my sample. Okay? And now, the reason you have a confidence interval is because you give yourself some room to play with, okay? And some room to play with means you can't, if I said it is going to be 0.999, then I don't have any, if it's not 0.999, I'm wrong. So instead I say, well, it's got to be between 0.8 and 0.95. Now I've got some room there in between. So a little cartoon that says, take a look at tomorrow's weather. The high temperature will be between -40 or between 40 below zero and 200 above. And it says, Garfield says, look, this guy's never wrong. Why is he never wrong? His interval was huge. Okay? Now, usually we choose a confidence level of 90% or higher because we want our audience to be very sure of our conclusions. So this guy could have said with 95% confidence it'll be between this. He could have said probably with 99% confidence it'll be between that. All right, now we get into more of this. The confidence level is the overall rate if the method is used many times, starting with the population, okay? And again, they're doing 16, and that's something new. Confidence level here, so we're not worried about what they were doing because that was earlier. Confidence level says, this is big down here. To say that we are 95% confident is shorthand for this. You must be able to basically repeat this sentence, okay, and in writing over time, multiple times through the next few chapters. 95% of all possible samples of a given size from this population will result in an interval that captures the unknown parameter. Okay? Another way for a confidence interval, to interpret a confidence interval for an unknown parameter, say this. We are however percent confident that the interval from blank to blank captures the actual value of the, and whatever we're talking about, the population parameter. So there's a couple sentences, those right there, that are going to be big when we get into these problems on confidence level and confidence intervals. Okay, so you need to take time to write those. The confidence level, so one more time, the confidence level tells us how likely it is that the method we are using will produce an interval that captures the population's mean if we use it many times. The confidence level does not tell us a chance that a particular interval captures the population mean. So it doesn't tell us a chance that one particular interval captures it. It tells us if we use the same method of sampling and we sample over time a whole bunch of times, we are this is how confident we are that we will find the mean in this interval. Okay? Now, it gives us a set of possible values for the parameter. So confidence interval gives us a set of possible values for the parameter, or plausible values. We interpret confidence levels and confidence intervals the same way we are estimating the population mean or some other parameter. All right? Now, it says, why settle for 95% confidence when estimating a parameter? So the price you pay for greater confidence is a wider correct interval. So to be more confident, you have to have a wider sample. Think about it. If I'm throwing a dart, this is my easiest one. If I'm throwing a dart at a dartboard, okay, I might say, look, all right, I'm 80% confident I can hit it in this circle. I'm 95% confident I can hit it in this circle. You see what I did? I'm more confident. Why? Because my interval is bigger. I got more room. I got more variation. I got more room to miss. Now, I could say, look, I'm 99% confident I can get it in this interval. So that's something to think of. The more confidence you have, the wider your interval is going to be. Greater confidence, bigger interval. Now again, estimate plus or minus the margin of error. So the general formula for confidence intervals is this. The statistic plus or minus the critical value, and we'll get that in a minute, times the standard deviation of the statistic. So that takes us through that question, okay? Now, there's the formula again for you up here. Properties of confidence intervals. We can go through those. The margin of error is the critical value, okay? So we'll talk about what is critical value. Some people say, what is that? That's the margin of error. We'll talk about it. Times the standard deviation. So critical value times standard deviation actually gives you your margin of error. If you talked about a poll and it said 47% vote for this candidate, but it said the margin of error was 2%, that means it could have been 49%, it could have been 45%. It's somewhere in between there. Same thing we're talking about with confidence intervals. The user chooses the confidence level and the margin of error follows from this choice. So you pick the confidence level. Now normally we're going to pick 95% because we want to be very confident. But again, the margin of error is going to be different on if you're 90% confident than if you want to be 99% confident. If you want to be 99% confident, you're going to have to give yourself a bigger margin of error. If you want to be 90% confident, well, your margin of error is a little less. But your confidence is also a little less. The critical value depends on the confidence level. So what critical value you put in depends on the confidence level. Greater confidence requires a larger critical value. Okay? And your standard deviation will depend on your sample size. So if you look at this, 80% confidence, you can be 80% confident that it's in between this part. But to be 95% confident, you had to extend and say, I'm 95% confident that it'll land in between this part. You've given yourself a little extra room just in case it lands out here or out here. You're still right because you're 95% confident, but it's because you've given yourself more room. All right? Okay. Now, using confidence intervals, you have to find three things first before you can use a confidence interval. Number one, you have to show that it's random. The data should come from a random sample or a random experiment. It's got to be random. If somewhere in the problem it doesn't say it's random or doesn't infer that it's random, you cannot do it. Okay? It's got to be approximately normal. It's never exactly normal, but it can't be skewed either. It's got to be normal. So it needs to be exactly, on here it says exactly normal if the population distribution is normal. It's going to be approximately normal, okay? Now, N needs to be sufficiently large, which means greater than or equal to 30. And if we do proportions, which means we're going to like probability, then we go back and make sure that our rule of thumbs work, and we can remember those when we get there. Independent. Individual observations are independent. That means the sample size should be no more than 10% of the population size. So again, if you have a population of 500, the biggest your sample should be is 50. And these formulas, this one, and this one, the 10% of the population, the NP is greater than or equal to 10, and the N1 minus P is greater than or equal to 10. That all came from the last chapter. So you've got all that back. Okay, again, in another setup here. All right. So basically in this section, let's summarize what all we learned. We learned to estimate an unknown population. You start with a statistic that provides you with a reasonable guess. So you start with a statistic that provides you a reasonable guess. Then the chosen statistic is called your point estimator for the parameter. That's your estimator. So you're going to get a problem, you're going to estimate with the information you have, a point estimator. Then you're going to make a confidence interval. You're going to take sample data and you're going to estimate with the confidence interval. The interval has two parts, okay? An interval and a level. So an interval is from here to here, and a level is how confident you are. And it's going to be estimate plus or minus the margin of error. And the formula to do that is statistic plus or minus critical value times standard deviation. So if you remember, margin of error is critical value times standard deviation. And we're going to actually go into these specific problems now.